This is our lecture 3, conversion of number system. So we have 12 conversion in our chapter 3. Let's start. We learn technique 1 and 2, that is decimal to binary, octal and hexadecimal, and technique 2, binary, octal, hexadecimal to decimal. That means we learn all of the conversion related with decimal number system. That means decimal to binary, decimal to octal and decimal to hexadecimal. Technique 1 have 3 conversion and technique 2 have also 3 conversion opposite of technique 1. And now we can easily say that we don't have any conversion related with decimal number system. Now we have to learn technique 3. Here octal to binary, technique rules number 7. Rules number 8, binary to octal. 9, hexadecimal to binary. Rules number 10, binary to hexadecimal. Rules number 11, octal to hexadecimal, and 12 is hexadecimal to octal. That means all of the number system is are in technique 3. Okay, so at first we have to remind something. Technique 1, D2 hop. Here we converted like decimal to binary, we have to divide it by 2 for integer part and multiplying by 2 for floating part, and for octal part we have to divide it by 8 and multiplying by 8, also hexadecimal part. And technique 2, binary, octal, hexadecimal to decimal. So here we have to place our position for each of the digit, like 6 has 0, 3 1 and 5 have 2. So this is our technique 2. Now we are going to learn technique 3. Here decimal number system is not available here, right? So when decimal number system is not available in any kinds of conversion, we can convert this like in one rules. Okay, so here is technique 3. At first we have to learn octal to binary and binary to octal. Now let's have a number, octal number like 732.04. that is a octal number and we have to convert it into binary number. Also I write a number for binary 101.101.1. So this is in binary, we have to convert into octal number system. So how can we convert this? At first we don't know any of the conversion. Okay, so how can we convert this? At first we have to generate the system of conversion. Okay, how can we invent this? So at first the base of the octal number system is 8. We write this base 8 and we have to go in a binary number system. The base of the binary is 2. Now how can it possible? 8 is not equals to 2, right? So if we equal both of the side, so how can it possible? If we put the power for 2 is 3 and 8 have the power is 1. So here you can consider 8 as an octal and you can consider 2 as a binary. Now the system or the converting rules has been generated. How can? So in octal we are going to binary number system from octal. So we have to convert for each of the digit. When we are going to convert for binary, each of the octal digit will be converting for binary for 3 numbers or for 3 digit, like 7. At first I need to write this number 732.04. so each of the digit of octal number system will be converting for binary and they will be for 3 digit. Okay, like 7 will be in 3 digit, 3 will be in a 3 digit, 2 will be in 3 digit. Each of the digit will become in 3 digit for binary number system. Okay, so how can we know that what is the binary of 7? So at first we have to learn the concept of the binary number system. Let 0 and 1, let in our daily life we don't have any digit except 0 and 1. So what will be the next digit after 1? Adrika, can you tell me?
Sir, 10.
Yes, right, 10. And after that we don't have anything, just we have 0 and 1. So after the 10 we will get 11, right? Please unmute your microphone, everyone, please.
Yes, sir.
Everyone, unmute your microphone and tell me after 11 what we will get.
100.
Yes, we will get 100. And after that
111.
101 should be the next digit, right? Okay, so then
110.
very good,
111.
110 will be the next, and after that we will get 111, right? Okay, so what will be the next digit? It will be 1000. Okay, so we don't have any digit except 0 and 1, so we can write in this way. So if we write down this binary digit, we already know the decimal number for this binary digit. What is this? 0 for 0, 1 for 1, 10 for 2, 11 for 3, 100 for 4, 101 for 5, 110 for 6, 111 for 7, and 1000 for 8. This is the concept actually how we can get the binary number system. So for 7 we will get 111. So we can write this 111. That means if we in a octal number system and if we want to go to in a binary number system, we have to convert in a 3 digit of binary. Okay, so 7 will be 111, and what is the digit for 3? So we will get 11. So here is 2 digit, so we write down here 11. So we have to write in a 3 digit, so we put 0 before this digit, so we'll get 011. If we write like 11, it will be wrong. Okay, so here we have also another technique for finding binary digit or binary number. How can we get? We will get from a chart. This chart represent the binary of octal number. This chart, the headline of this chart is 421. Okay, if we add this add those 3 digit, 4 plus 2 will be 6, 6 plus 1 will be 7. That means these chart only applicable for octal number only. Okay, because we know octal number system contains 0 to 7. The highest value we will get from this chart is 7. So that means we will get the binary number from this chart for only octal number system. So here we will get 7. So how can we will get the binary for 7? If we need 4 for making 7, so 4 plus 2 6, 6 plus 1 7. When we need this column, we'll write here 1. When we don't need this any of this column, we'll write there 0. So now 111 for the 7 and 3, so we need 2 and 1, this 2 column, that means 2 plus 1 will be 3, and we don't need the column of 4, so we put here 0. So the binary is 0 1 1. Also we need 2, so here is 2, we don't need any of the column, so we put here 0 1 0 0 1 0. If we see like 2 for 1 0, so here we'll get 1 0, and for 3 digit we put before this 1 we'll get 0, so 0 1 0 for the 2. So and also we need the binary for 0. Student will do this mistake, they will write here 0, but this is not correct formation because we need 3 digit for each of the octal number. Okay, so we have to write here 3 of 0. That means we don't need any of this column, so we need to put here 0. Also here is 4, so we need here 1 because 1 is correct for this column, and we don't need any of them, so 100 for 4. So this is the binary of octal number system. So this is our result, like 111 011 and 010, here dot, and 000 100. This is our binary number. Everyone, do you understand?
Yes, sir.
This is a very simple rules. Where you don't have the decimal word, you can convert like this way. You just put this base of the number system octal, and we have to go in binary, so we put here the 2 for binary, and we have to equal for each of the side, left side and right side, by using power. Okay, so also we have a number like 1011.1011. So this is the binary number, so we write here at first 10111.1011. Now we have to convert this binary to octal. So here at first I write the base of the binary is 2, and we have to go in a octal number system, so we write here 8. So how can we equal each of the side? So we can put here 3, and this is for 1. And now we can tell that for binary number system we will make 3 digit for each of the octal number system. So how can we make this 3 digit? Okay, so I have to change my pen color. So now if we consider that you are in a point, so you can go left and you can go right. Whenever you want to go left, you will marking this 3 digit, and also if you go left you have 2 digit here, and you have to make 3 digits, so you put here 0. Then you have to go right, so you mark here for 3 digit, and also we have 1, that means 1 digit, so we have to write 2 digit for here, and this is 0. So if you consider like how can we write 0 after this, after the positional value, after the floating point, it is absolutely correct formation, like 0.4 is equals to 0.40. There is no mistakes. Okay, so also you can place 0 before the number for any kinds of integer part, like 5 is equals to 0.5. This is also correct. Okay, so you can easily put 0 before this integer part, and you can easily put 0 after the floating part. Okay, this is absolutely correct formation. Now you have to marking each of the bit. So now what is the value of 010 for octal system? So again we have to write this chart like 1 2 4. So I write here 1 2 4. This is our chart and this is our headline. So now how can you write the value of this binary? So you have to place you have to put the value 010 here in this chart, 010. Here 1 is applicable for 2, right? This column satisfying our system, so the value of 010 is 2. And 111, so here we write 111. So we need each of the columns, so you have to adding each of the headline of those columns. So 4 plus 2 is 6, 6 plus 2 is 7, so here is 7. Now 101, so 101, what is this? So we need 2 column, 4 and 1. So if you add both of them, so you will get 4 plus 1 is 5. And 100, so we put here 1001. We need just this column, this is called 4. So you will get the answer is 27.54. Here is your octal value. Okay, both of the system is very simple, and you have to just remind this formation whenever you don't have the decimal, the word decimal, you can converting by this way. Okay, have you any question?
No, sir.
Okay, now all of the system are same in technique 3. So here is our technique 3 and rules number 9, hexadecimal to binary, and 10 is binary to hexadecimal. So I have to write a number first for hexadecimal. We write here like 4A 9.7 E 6. This is the value of hexadecimal and we have to convert it into binary number system. So here we also don't know the rules, so how can we create these rules? At first we have to write the base of 16, base of hexadecimal is 16, and you have to write the base of binary is 2. Now how can you convert this? Here this is not the equal number, so we have to equal by using this power. So now in a hexadecimal number system we have to convert each of the digit in a 4 digit for binary number system. Like at first we write this digit again, 4A9 7E6. you must write here like this way, and each of the digit become in a 4 digit for binary number system. Now we also need a chart for this number system. You can also using these things for the converting of binary number system, like for 4 we will get 100, right? So if we write here 100, we need 4 bit, so we put here 0 for satisfying our rules. So 0100 is the binary for 4. Also we need the binary for A, so now we have to write the chart 1 2 4 8. We already know that hexadecimal number system contain the value 0 to f, that means if consider 15. If we add all of the headline like 8 plus 4 is 12, 12 plus 2 is 14, 14 plus 1 is 15, that means this chart only applicable for hexadecimal number system, because all of the digit will be available in hexadecimal number. So here you can you have to write this binary. So 4, this column only need for making the binary for 4, so we don't need any of them column. So 0100, and for A it means 10. I already know that, like A means 10, B represent 11, C for 12, D for 13, E for 14, and F represent 15. That means A indicates 10. So 8 plus 2 is equals to 10. That means we don't need those columns. So 1010 is the correct binary for A. So now 9, 8 plus 1 will be the 9. So this part 00. So result is 1001. For 7, we have to make this way. So 4 plus 2 6, 6 plus 1 is 7. So here we don't need this column, here is 0. So 0111 is the correct binary for 7. Also E indicates 14. So 14, how can we get 8 plus 4 is 12, 12 plus 2 is 14. We don't need this column, so 1110 is the binary for E. Also we need 6, so 4 plus 2 is 6, so we don't need those column. So here the result is 0110, 0110. So 0100 and 1010 for 9, 1001. Here is the point. Then 70111 for E, 1110, and for 6 0110. This is our binary. Okay, do you understand this part? For binary to hexadecimal, 100111 0.11. This is the binary and we have to convert it into hexadecimal. So if we don't know the rules, we have to create the rules. Here 2 is the base of binary and we have to go to in a hexadecimal, so the power will be the 4 and here 1. So that means 4 bit of binary become the 1 bit for hexadecimal, right? So here we write again 1001110.11. Now you can go left and you can go right. So whenever you want to go left, you have to mark 4 bits of binary, and also you will get 3 bit here, and so you have to put 0 for satisfying our rules. Also we have to put here 0 for the floating part. So now we also need this chart again. So 8 4 2 and 1. So here 0100, we put here this value 0100, we'll get only 4 for this binary part. We write here 4. Also 1110. So that means, so 8 plus 4 is 12, 12 plus 2 is 14. So we'll write here 14. So we already know that hexadecimal number system does not contain 14. So that means we have to write here E, because we already entered in hexadecimal number system. Whenever you entered in a number system like hexadecimal number system, you have to write this value of 14 or 13 like this way. So 14 for E. Also we will get 1100. So 1100, that means 8 plus 4, we need those two columns. So 8 plus 4 is 12. So we write here 12. 12 indicates C. So we write here C. So the ultimate result is 4E point C. This is for hexadecimal number system. Okay, have you any question from this part? Our last conversion is octal to hexadecimal and hexadecimal to octal. Here we have no extraordinary rules. We just combine those 4 rules for this conversion. Okay, so octal to hexadecimal. Now we write octal number like 435.06. So octal system we have to go in a hexadecimal number system. So here octal, the base of the octal is 8 and the base of hexadecimal is 16. So this is a technique actually. So how can we go? We cannot write here this power, because if we use this power like 8 square, you will get 64. This is not actually 16. That means you have to multiplying by 2 for making this 16. So that means this equation tell me that we have to go from octal to binary and binary to hexadecimal. Octal to binary and binary to hexa. We already know the rules. Okay, how can we convert these two items? So here is 2 step. Step 1 indicates octal to binary, and step 2, this will represent binary to hexadecimal. So how can we convert each of these conversions? So we have to write 435.06. this is the octal number. So at first we have to go in our binary number system. We already know what is the rules, because this is the rules number 7, octal to binary. We have to convert in a 3 digit of binary. Okay, so I don't want to write this chart again because I already know the binary of this part. So if you don't know, you have to write this chart for making those binary. Okay, so 4 means 100, 3 means 011. I know that, and that's why I am writing directly. So 5 means 101, 0 means 000, and 6 represent 110. So the ultimate result is 1 0 0 0 1 1 1 0 1 point triple 0 0 0 0 and 1 1 0. This is the actual binary. Now we have to go from binary to hexadecimal. So we already know that the rules of binary to hexa. This is the rules binary to hexa. So we have to convert like this way. So the rules is you have to mark for 4 bits of binary, like this 4, this 4, this 1. So we have to write here 3 bit. Now this 4, and we have to write here 2 of binary digit. So our ultimate result will be, at first we have to write this arrow, and this is the actual system. Okay, so 0001, this is called 1, 0001 again, this is called 1, then 1101, 8 plus 4 12 13, 13 means D. I know that you can convert by this chart. So 13 is D. Now 0001 again will get 1, and 1000, this is called 8. So the hexadecimal result is 11D.18. So this is our ultimate result for hexadecimal. So here we will get the two part of this math. First part represents step 1. This is rules number 7, octal to binary, and second part is step 2. This is rules number maybe binary to hexa, rules number 10. So this is rules number 10. So we need to convert octal to hexadecimal. Okay, so also hexadecimal to octal, we also need again two of them rules. So here we write 9D point CA. Okay, this is the hexadecimal value. We have to go in our octal system. So how can it possible? At first we write here the base of the hexadecimal is 16, and you have to go to octal number system. So base is 8, and how can we equal both of the side? You have to divide it by 2. So here we have to go hexadecimal to binary and binary to octal. So also we have the two steps here. So step 1 is hexadecimal to binary, and step 2 binary to octal. So here we have to write the value 9D.CA. So we already know the rules. Hexadecimal to binary, rules number 9. Here we need 4 digits for each of the hexadecimal number. So you can write this chart again for this conversion, but I already know that, so I don't need to write here again. So 1001 is the binary for 9, and D means 13, so the binary is 1101. So C means 12, the binary of 12 is 1100. A means 10, the binary of 10 is 1010. So the ultimate result is 1 and 1101. Here is the point, and 1100 and 1010. Okay, we have the binary. So now we have to convert in our octal system. We already know the rules. How can we convert these? We have to mark 3 binary bit. So here's 3 3 and here's the 2 bit, so we have to put here 0. Also if you go right, so here 3 bit, 3 bit, here is the 2 bit, so you have to write the 0 after this 0. So the octal number will be 0 1 0, this binary represent 2, 0 1 1 means 3, 1 0 1 represent 5, 1 1 0 6, 0 1 0 will be 2, 1 0 0 is 4. So the binary is 235.624. This is our octal number. So here we also have two step. Step 1. Step 1 is hexadecimal to binary. We already know the rules. Hexadecimal to binary is rules number 9. So here rules number 9 for step 1. And binary to octal. Binary to octal is rules number is 8. So here step 2, binary to octal. Step 2. We need the rules is 8 here. So we converting all of the number system here. Today we learn technique 3. Here 6 conversion available. So octal to binary, binary to octal. Here rules number 9, hexadecimal to binary, binary to hexa. That means the relation between binary and octal is 3 bit. Okay, the relation is 3 bit for binary and octal, and the relation between hexadecimal and binary is 4 bit. Okay, so and the rules number 11 and 12, actually these two rules actually are regenerated rules of rules number 7 8 9 10. Okay, so here the two step available in this in these two rules. Okay, so octal and hexa to octal. Okay, have you any question from today's class? আচ্ছা, আমি কারো কথা শুনতে পাচ্ছি না, আমাকে একজন একটু বলবা। যারা, তুমি কি বুঝতে পেরেছো আজকে সম্পূর্ণ ক্লাস?
Yes, sir.
দেন হচ্ছে আদ্রিকা,
Yes, sir.
আরায়ান আহমেদ,
Yes, sir.
লাবণ্য বড়ুয়া, নুজাত তাবাসুম।
Yes, sir.
Okay, very good. So we already completed our 3 techniques and 12 conversion. So this is our homework. You have to maintain in time. আচ্ছা, সো আজকের ক্লাসটা আমাদের টোটাল 12টা রূপান্তর ফুল কমপ্লিট হয়ে গেল। তোমরা যেটা করবা, বাসায় এই হোমওয়ার্কগুলো করার পরে আবারও সেম একই রকম ভাবে পিডিএফ করে দেন তুমি হচ্ছে এই জিনিসগুলোকে আমাদের পেজে এবং গ্রুপে আপলোড করে দিবা, ঠিক আছে? এবং তোমরা আরেকটা বিষয়, যারা ক্লাসে জয়েন করতেছো রেগুলার, তোমরা কিন্তু যদি হোমওয়ার্ক করে জমা না দাও, আমি কিন্তু তোমাদের ফাউন্ডেশন কিন্তু চেক করতে পারবো না যে আসলে তুমি কতটুকু বুঝলে বা কোথায় ভুল করলা। আইসিটিতে মেইন সমস্যা হচ্ছে স্টুডেন্টরা অনেক পারে, কিন্তু পারার পরে যেও পরীক্ষা হলে কিছু সিলি মিস্টেক করে, যেহেতু এগুলো সব ডিজিটাল বিষয়, তাই না? তোমার একটা মিস্টেক হতেই পারে, 0 জায়গায় তুমি বলবো 1 বসাইতেই পারো। হ্যাঁ, তুমি হেক্সাডেসিমাল এন্টার করে এর জায়গায় না লিখে তুমি 14 লিখতেই পারো। সো এই ভুলগুলো তো তোমার চোখে ধরা পড়বে না, এগুলো আমার চোখে ধরা পড়বে। এই জন্য হচ্ছে হোমওয়ার্কগুলো করে দেওয়াটা ইম্পর্টেন্ট। যদিও তোমরা সবাই করতেছো, এই জন্য থ্যাঙ্কস তোমাদের সবাইকে যারা করছো। আর আমি এই হোমওয়ার্কটাকে চেক করে তোমাদেরকে আবার গ্রুপেই দিয়ে দিব যারা হোমওয়ার্কগুলো করছো। আমি এখনো চেক করার সময় পাইনি, বিকজ অফ আমি একটা আমাদের একটা ওয়েবসাইটের প্রজেক্ট নিয়ে আমি একটু বিজি, দ্যাটস আমি একটু সময় পাইনি। তো আমি সময় করে চেক করে তোমাদেরকে আবার রিসাবমিশন করে দিব, ঠিক আছে? আচ্ছা, আরেকটা বিষয় হচ্ছে তোমাদের এক্সামটা আমি নিব হচ্ছে নেক্সট উইকের মানডেতে, মানে নেক্সট ওয়েডনেসডে তোমাদের যে ক্লাসটা হবে সেটা হবে হচ্ছে বাইনারি অক্টাল এবং হেক্সাডেসিমাল নাম্বার সিস্টেমের যেটা অ্যাডিশন, হ্যাঁ, যেগুলো যোগফলগুলো করতে হয় সেগুলো আমরা শিখবো নেক্সট ক্লাসে। তারপরে ক্লাসে আমরা এক্সামগুলো নিব, অ্যান্ড এক্সামের পর থেকে আমরা চ্যাপ্টার 1টাকেও প্যারালেলি শুরু করব। অ্যাকচুয়ালি আমি শুরু থেকে চ্যাপ্টার 1টা প্যারালেলি শুরু করলাম না, কারণ তোমাদের ফাউন্ডেশনটাকে আমি একটু স্ট্রং করতে চাই আগে চ্যাপ্টার 3, কারণ ম্যাক্সিমাম প্রশ্ন চ্যাপ্টার 3 থেকেই হয়। সো আফটার দ্যাট আমি এটা করব, ঠিক আছে? তাহলে সবাই আজকের জন্য এই পর্যন্ত, ভালো থাকো, সুস্থ থাকো, আর হচ্ছে নেক্সট ক্লাস অবশ্যই ইন টাইম জয়েন করবা। আল্লাহ হাফেজ।